So in data center, Nexus switches is the main role. They play a vital role. The normal switches, the catalyst switches, the Ethernet switches are not enough. Why? Ethernet switches, they understand only Ethernet. But when you speak about data center, not only Ethernet, the fiber channel also comes into picture. So we need a switch that can understand both Ethernet as well as fiber channel. In a traditional data center, if you see, you can see two different switches, two different engineer groups in one single data center. You will have Ethernet LAN engineers who work on switches, catalyst switches, configuring port channel, VLANs, spanning tree, sometime routing. Also, you will have another team which is working on SAN switches. The SAN switches, storage area network switches, where there also they will do FC port channel, fiber channel, port channel, zoning, and much more. So you need two separate engineering teams to take care of one data center. The SAN was separate, LAN was separate. Whatever I have said, I think you have visualized it. So we have two parts. Let me try to get some pictures from. So here we can see we have two type of network here. We have LAN separate. When you say LAN, you have LAN switches, routers, all Ethernet, and you have SAN. So in the SAN cloud, you will have SAN related SAN switches. Now to combine, you need two engineers who understand SAN and engineers who understand Ethernet. They need to come together. Only then, whenever someone wants to access the remote LAN, they can access using Ethernet. When that same device wants to access a remote storage, they can go through the SAN switch and access the storage. So both needs to be in data center, LAN and SAN, both are needed because sometimes you will go internet. For that, Ethernet is needed. Sometimes we'll go to a remote storage box. For that, you need a protocol that the storage world will understand, the SAN world will understand. For that, FC is what the protocol, FC, iSCSI, SCSI, these are all the protocols that works on SAN. So you need switches that can carry that Ethernet traffic to Ethernet and SAN traffic to SAN. Early days, it was two separate network, LAN network and SAN network. But in today's network, after Nexus, one box itself can do both the job, LAN as well as SAN, in one single box. That's one of the reasons why we call this as unified switch. Unified. Now, You see, the Nexus devices, I told you they are not only a LAN switch, they are also a SAN switch. But early days, it was not like that. You see, for LAN, you had a separate network. So from each server, you will have an Ethernet wire. And for SAN, you have a separate SAN switch called MDS, multi-directory switch. Even today, we have MDS switches. But today, MDS switches are unified, multi-directory switch. But today's MDS are not only SAN, they can also work as LAN device, unified. But early days, we had a separate SAN switch. So you need to have a FC card, fiber channel, and Ethernet card, NIC card. So from the NIC card, you will have Ethernet connection. From the FC card, you will have fiber channel. You'll have fiber channel connection, FC port, fiber channel port. So later, what Cisco did is Cisco came up with a design called CNA. This is without CNA, but this is with CNA. I would like to explain it in detail. What is CNA? Converged network adapter. Converged network adapter. Converged. See, the word converged means, unify, put together. A network adapter in which both LAN and SAN can operate. That's why it is converged. The network adapter which can respond to both FC as well as Ethernet. A network adapter which has got both MAC address for Ethernet and FC IDs or WWN address for FC. Okay, question. Ask me the question. No. Physically, it looks one port. Looks same, one single port. Inside the drivers, the transceivers are two. Physical port is only one. See, always we need redundancy. For redundancy, we will have usually two NIC cards, NIC card 1, NIC card 2, and then we used to have two FC card, fiber channel card 1, fiber channel card 2. So two FC cables, two Ethernet cables from each server. Even if one Ethernet cable fails, you still have the Ethernet connection. You understand why 2 2? So here also you have two Ethernet card, two FC card, FC port. So totally 4 wires from each server. Two FC wire, two Ethernet wire. One server, 4 wires. So Cisco came up with a new adapter card called converged, means unified, combined network adapter. Now you have only 2 instead of 4 because this can carry FC as well as Ethernet. This also can carry FC as well as Ethernet. 2 ports. Physically, it is only one port. Logically, it has got trans receiver for both FC and Ethernet. No, it will be different. It will be like SFP. So you can see here in one server, 2 cables got reduced. Instead of 4, now you have only 2. If I have 50 server, instead of 200 wire, now it has gone to only 100 wire. It's a very big difference. See, 200 wire cost, maintenance, very difficult. 50% of the cables. Don't always focus on the cable cost, just focus on the maintenance. Maintaining 200 wire and maintaining 100 wire, very big difference. Tracing the wire, tracing one wire in 200, tracing one wire in 100. How big difference it is. So CNA opened a way for FCOE. See, it need not to be always SFP port. It can also look like an Ethernet port, RJ45. It depends. You have both. It will look like a Ethernet card, but it can transport FC over Ethernet. So now you see, if you have a unified converged port, then switch also need to be a unified converged. See, you are going to send both Ethernet and FC on one wire. Now, if the switch don't understand FC, or if the switch don't understand Ethernet, problem. You got it? Yeah. So you need a switch which can differentiate the signal and say, this is an FC signal, I need to handle like this. This is an Ethernet signal, I need to handle like this. So if you will have a switch like that, we call it as unified or converged switch. Nexus is that unified switch. Nexus is that converged switch. So earlier you used to have 4 switches. Now you got only 2 switches. And this switch now will take all the Ethernet traffic sent to the LAN and take all the FC traffic and send to the SAN. You see? So not only the number of ports on the server got reduced, even the number of switches in the distribution layer got reduced. This is to help us understand why Nexus switch. The catalyst switches cannot do this. When you have a CNA adapter on the server, you cannot use a catalyst switch. Catalyst switch don't understand FC signals. When FC traffic sent out from the server, catalyst switch don't know what to do. It will simply drop. You need a switch that can differentiate between the FC signal and the Ethernet signal. Every port on Nexus switch can do this. It can do Ethernet job as well as FC job, the unified ports. But again, it depends on the line card. If your line card is FC OE enabled, if your line card is converged, if your line card is unified, then it is possible for you to have this servers with CNA adapters. But in Nexus, you will have many line cards. So what they do, they will buy one IO module with unified ports. Each port can be FC or Ethernet or both. And they will buy another card only Ethernet. They'll buy some other card with only FC. So this back panel understands all this. So not only line card is unified, even the switch is also unified. That's why it can take signal from Ethernet as well as the FC line cards. The high-end models like 7000 series, 9000 series, even 5000 series, the bigger models will have different type of line cards. See, that is your wish. You can buy all line cards as unified line card, or you can buy one, but depending on your need in your environment. What is your need? See, I want to connect all the storage directly. Here, in this picture, if you see, they have a separate SAN switch to connect all the storage box. But if this itself is bigger, I no need this switch. I'll connect all the storage box to the SAN module and all Ethernet to the Ethernet module and all the servers to the unified. So here I need three modules. One is unified to connect to the server. Another one is another line card, another slot with only Ethernet, another slot with FC. This is a nice picture which explains what we are talking now. You see, the server has got a CNA adapter. Now, which means this can take Ethernet traffic and the FC traffic consolidated. So now the switch, the switch port, this port also need to be an FCOE port, a converged port. So you got a module with the converged port. And also, you see, there are some ports here, they are Ethernet only. Some ports here with our storage, SAN port, FC port only. Which means the switch is a big switch with the FCOE ports and with Ethernet only ports and with FC only ports. You see? So this is a unified switch. This is only possible through Nexus operating system. The switch with the Nexus operating system is what we call it as Nexus switches. NXOS. So it has got a SAN port, native fabric channel links can be connected. It has got a LAN port where the Ethernet links that carries Ethernet traffic can be connected. You have unified ports or unified wire where the LAN and SAN traffic can be received and sent. See, when When a traffic approaches on unified port, the port needs to have the intelligence to know this is FC traffic coming. So all the FC related engines will process it. This is an Ethernet traffic. Then all the Ethernet engines will process the packet. So the cleverness is not seen in the normal switches. Only a Nexus with the Nexus operating system, those switches have got this. So far, what I have explained is why Nexus in the data center. In the data center, we are not just communicating, we are also storing the data. So you have a storage box. You need a SAN network. You are not only storing the data and retrieving the data, you are also going online for various purpose. Like you want to talk to a remote office, you need to use the internet. You want to talk to a remote data center, you need to use the internet. You want to talk to the URLs that are in the world to download some projects, you need the internet. So data center and enterprises, yes. Let's think. Correct. Hmm. Unified. Hmm. Yeah. FCOE, that can be Ethernet port or SFP port, it depends. Even the Ethernet port, because it's an FCOE port, the look of the connector, the cable is Ethernet, but it is going to encapsulate FC, and it will be carried as Ethernet, but inside it is FC, fiber channel. So the receiving device, when it processes layer 2, it will know from the layer 2 packet type field, it will know whether it is a Ethernet packet or FC packet. Depending on the packet type, then the engine will be used to process the packet. Yeah. So forget about the cable type. When you go to the field, you will know. It is already there. You are not going to do that. It is going to be already there, set by the engineers who is coming from outside, deploying it in your organization. They will do everything. They will train you and they go. Your job is to maintain only. So don't worry about this physical stuff, layer one stuff. Layer one stuffs are taken care by the team who sold you those products to your company. They will do everything and then they will give you a training and they will say, this is what we have done. Now from there on, you need to take it. I was there as a cabling guy. I was deploying sorry, Nexus, and then I did all the cabling stuff, and then I gave it to the company. I trained them, I gave it to them. From there on, they took over. They're doing really well. It's now more than 6 years now, pro compliant. Initially, they called for a few help, and now they are using it without any trouble. It is running. If there's trouble, they would have called me. Now, what I'm trying to say is, Nexus switches has got both FC and Ethernet. So one engineer can handle both. So not only the wires are reduced, not only the switches are reduced, even the team size is reduced. You don't need to wait for an FC engineer to come, or you don't need to wait for Ethernet engineer to come. One engineer with both the knowledge, because the switch is same CLI which the Ethernet engineer has already known. All that you need to do is you need to understand the FC, and you will be able to configure FC also. So we can now reduce even the people. Even though people don't like, we do that. We don't like unemployment, but we will do all this thing in our environment. We'll say, hey, this is reducing the cost. Nexus, the land engineer can also now take care of sand. Then what will happen to the sand employees in the street, begging for next meal? So we desperately did a lot of things. That is why now slowly you are also out. AI has come, machine learning has come, artificial intelligence has come. Now all are in street begging. We'll continue doing this until we come 100% to the road. Now, introduction to Nexus is over. Let's see what all features this Nexus have got, which is not there in Ethernet. This introduction by Cisco, introducing Cisco Nexus switches and fabric in data center. This course gives you a complete knowledge on Nexus. In this paragraph, first paragraph, they have introduced to you one feature called VDC, Virtual Device Context. What is virtual device context? A device has been multiplied into multiple virtual devices. A physical switch is sliced into many virtual switches. Each switch is a context. Virtual device contexts, because you got many virtual devices out of one single physical Nexus switch. This VDC feature is not available on all series, only on 7000 series. Let me show you a picture. So if you see this picture here, it's one switch. It may be single, the picture may be single rack unit size, but in reality there will be many uh, modules in 7000 series, and you will have more slots. Here they are showing just only one slot. It is one physical slot. It is one switch, you see, but there are four switches I can create. The four switches are created here in this picture. Physically one switch. There is a yellow VDC, there is a blue VDC, there is a red VDC, there is a green VDC. Reddish brown. See the ports that are reddish brown. 8 ports are there. These 8 ports are grouped together to form one VDC. And see the blue ports. Those 8 blue ports are grouped together to form another switch called VDC-B. See the green ports, the left and in the right down. Those 8 ports are grouped as one virtual switch, and that switch is named as VDC-A. Likewise, you can create more VDCs depending on the license. depending on the license and depending on the supervisor module on the switch. What is a supervisor module? That's a control and management plane together. Control and management plane together. So there in supervisor module also there are some versions. Soup 1, Soup 2, Soup 3, Soup 2E, likewise. We'll talk about those differences later. And depending on the supervisor module and the license that you have purchased, the number of virtual devices that you can create is going to vary. Now, if you notice here, if I have version 1 supervisor module, I can have 4 VDC. If it is 2, I'll have 4 plus 1 admin VDC. If I have 2E, 8 VDC I can create and 1 admin VDC. But this is not fully updated. We also have more versions in supervisor module, which we can see in the data sheet. If you have 2E, and you can see here it is written number of VDC is 8 plus 1. It's the same thing here, it is written 8 plus 8 VDC you can give to customers and 1 VDC you can use it for admin. In 77 series or 7000 series, if you have 2E as a supervisor module, this is what you get VDC. If you will have supervisor module 2, not 2E, 2, then you get only 4 plus 1. If you have supervisor module 1, you get only 4. Supervisor 1 and 2 won't fit in 77 series. 77 series starts from 2E, 3, 3E. 3 and 3E will support more than 8 VDC. So that's your homework now. Ko, how about you? Did you get any answer, Ko? Okay, if you see here, we got different supervisor modules. 7,000 SUP 1, 7,000 SUP 2, 7,000 SUP 2E, 77,000 SUP 2E, 7,003. Now we were talking about the VDC. Look at this. 8 plus 1 admin VDC. 8 plus 1 admin VDC. 8 VDC you can create. Here now, in the 77th series, if you have 2E, and if you have a necessary license, you can go up to 8 VDC. One box, physical box, but you can have 8 virtual boxes. If you have this dual core Xeon processor, quadra-core, dual quadra-core, then you can have 8 plus 1 admin VDC in 7000 itself. This one we already 4 plus 1. On 7000, if you have SUP 1 with dual core Xeon, then you have 4 VDC. One of the VDC you can keep it for yourself for admin, or you can give it, it's up to you. Right. Apart from this, you see there are modules, input-output modules. This M series are mostly layer 3, but doesn't mean that it is not layer 2 capable. It is layer 2 capable as well, but it is designed more for layer 3 features. In that also you have a lot of series like N7K M to 24 port. This 24 talks about 24 port. X means gig Ethernet ports. This means fast Ethernet ports. Meaning here you see it is 6 into 6 ports of 40 gig Ethernet and QSFP port, QSFP plus. This is simply SFP plus. Here each port is 10 gig, here each port is 40 gig if you have this module. You can have multiple, correct. Splitters will be there. So, huh? Yeah, I can see that. CFP, SFP, SFP. These are the variations you need to Google. I was not having much idea about here. Here we can see the look. Not much difference, all looks more similar rather than Q. Q we have seen, it will be having a kind of holder kind of plastic here. We press and pull it. This also we hold it here and pull it. This is SFP28, SFP X, SFP. The difference is the speed, the year it was made a standard, all that stuff. Available in several different connection type. You can have LC or RJ45, blah blah. Mhm. Speed variation, data rate. These are all good to know for those who work in layer 1 level. So basically, CFP has got more throughput, 40 or 100 gig. KSFP plus 40, SFP plus 10. SFP is 1 and SFP plus is 10. Again, PSFP. Fine, you know the difference. Now, our purpose is to know about VDC. We got the answer here. And I'm just introducing, there is something called M module where you will see NetFlow support and VPC support. VPC is supported in both VXLAN. Okay, this is what you have: BGP, EVPN, encryption, MPLS. You cannot expect this in F port, F module. F module, you cannot expect all layer 3. You will have more layer 2 and some layer 3. You see VPC support is there, Flex is both supported there and here, but you don't see MPLS, you see? You don't see MPBGP, VXLAN. It says VXLAN EVPN, but you see here? No. And this all depends on the hardware readiness. But in the M module, you can see readiness of layer 3. In M module, you will see MPLS, OTV, Lisp. These are all not there. VDCs, F series intercomparability. Fine. So you can take some ports from F, some ports from M, and you can make it as one VDC. That's what here it means. F series interoperability in same VDC. So I can take some port of M module to have VXLAN EVPN and MPLS, and some port of F module and bind it in one VDC. Right. And so these variations need to be known to us when we are working on Nexus 7000 series. It is not just one switch. You see, a lot of components makes the difference. Depending on which component you put together. If you have all F module and SUP2 E on 77,000, then the story will be one. And if you have 3E, the story will be another. So the chassis differences, number of slots, you see, that also matters. How many IO module? If you have 4, then you will have 2 slots for supervisor modules. See, these 2 are supervisor modules, and these 2 are IO modules. Likewise, the number, the chassis number, if you have 7,009 slot, then 2 slot for supervisor and 7 slot for IO. So you just subtract 2 from it. If you have 18 here, then subtract 2, 16 IO modules. It's really a big boy. Let's click and see. Very big one. You see? And 2 in the middle, it is actually this cap is hiding it. This lid is hiding it. You have 2 supervisor module backside. This one. When you open the door, you just press this button, you can open the door. When you open this, you will be seeing supervisor module. There is also a 3-dimensional view. Let me try to